got loyalty, got royalty inside my DNA.
We can definitely start. Our loyal viewers who always watch us are here. And if you're not here, then that shows you. Cool. Well, welcome everyone to PL Talk. This is actually a very it's going to be a great and very dramatic episode, because not only do we have Ranjit Jhala and his student Nico Lehmann. Yes. To talk about our recent paper on STORM. I actually had very little to do with this paper since 2018. It is now 2021. So as you might guess, there's a story there about how this paper came to be. So not only are we going to talk about securing web applications using refinement types, which is already very out there, because look, like the cool thing about this paper that took so many years to figure out is automated verification statically of security properties across the application and database. This is not easy, despite what ICFP 2019-2020 reviewers might say. We have a drama about that, but the original student, who you may or may not have met before, who worked on the paper, may or may not be a mystery guest later today. So yeah, spread the word. This is a juicy one. But yeah, so for everyone who's not familiar, PL Talk is a weekly live stream by Hongi and me, although we're considering the idea of taking a summer vacation. So we'll stay tuned. It started randomly. We just started doing it during lockdown. And yeah, I am Jean. I am, well, I'm a co-host, and I'm also the founder of a company called Akita Software. We're doing API-centric observability. If you haven't heard of that, that's because we're trying to make it a thing. We think observability is too hard and static analysis is not very useful when you need to look across your system. So that's what we're doing. And before we go on, I would like to say two things. One is that it's the day before Juneteenth. So I understand a lot of people are off work and, et cetera, but, we're very glad at PL Talk. This is now a federal holiday, and we encourage everyone to learn about the history of Juneteenth and, maybe attend events locally or something like that. The Juneteenth conference is also going on today. So if you're in tech and you want to understand how to better make tech a better place for Black people in tech, Juneteenth Conf is a good place to check out. And then the second thing is it's NBA playoffs. So I'm wearing my Hawks supporter outfit. It's not an official Hawks jersey, but I recently became a big fan of the Hawks because they're a good team. Go Hawks. Is that your Hawks hand gesture, Ranjit? Is that a hawk? No, we cannot even hear Ranjit anymore. He's just making coffee. Wait, can anyone hear me?
I can hear you. Yeah.
I can hear you. I just muted myself.
Oh, is that your Go Hawks gesture? Cool. And so, Hongi, do you want to just introduce yourself really quickly, and then I will give some more background on Ranjit and Nico.
Sure. Yeah, I'm Hongi. I'm the other co-host, the PL amateur, as it were. Yeah, I think that's all I need to say about myself.
Cool. So well, Ranjit and Nico really don't need much introduction. They're just very cool, but I'll introduce them anyway. Ranjit is a professor at UC San Diego. You may know him for his really great work on liquid types, general verification, or his music video performances. And then Nico is his student who took a years-long effort on the STORM paper and finished it.
And booted it across the goal line.
Yeah. And so yeah, so I think that actually since people have heard from Ranjit before and Nico, something we like to do in the beginning is just have people like tell a little bit about how they came to be working on this project. So, how did you become Ranjit's student? How did you start working on STORM?
Yeah, sure. So I think everyone started back when I doing my master in Chile. So I have the opportunity to work with Eric Tanter. And if you don't know, Eric,
he's the best,
yeah. So he bootstrapped the whole PL community in Chile. So before him, there was no PL at all. And now we have a lot of people doing great PL research there.
Yeah, let me link his profile.
So I remember taking his grad PL class, and by the end of the class, you had to like choose a paper and do a presentation about the paper. And I chose, if I remember correctly, the refinement types for Haskell paper by Nikki. I don't know, and I got so involved in liquid types and refinement types, and I even made my master's about that. I combined with gradual typing. So later, when I was looking for a PhD, Ranjit was like an obvious choice that was in my mind. So I came to EST, and but that time the project was being carried out by Rose, that I must say made most of the, I think most of the work was made by her. And I just the project and shared it to the final line. And yeah, now we have the paper in STI.
Yeah, and Ranjit, you told a great story last time about how you got into PL in the first place. Do you want to just like give the TLDR of that? Oh no, Ranjit is muted again.
Sorry, can you remind me? What did I've forgotten. I can't just can you remind me what I said? Because there's many different possibilities that could have gone.
It was
I
really
usually
good.
hold my undergrad advisor, Sanjeeva Prasad, responsible.
Oh, you didn't even say that part. You said this whole other part.
Which
you
other
said
part?
Model checking, something,
right. That's how I got
yeah.
into, right. Well, there was that. That's how I got into types, I guess, is when I was interviewing at UCSD, actually. We had a colleague at the time, he's passed since, Joseph Gogan, who was, among many other things. By the way, he's actually connected to this because Joseph Gogan and Jose Messiger in 1982 wrote the kind of the canonical paper on non-interference, which is like, that's like from which all the theory of information flow, in the end, all the, like, including this OSDI paper, actually, in the end, with all these security information flow things, what you want to prove is a property called non-interference. And as it happened, Joe Gogan was the guy who came up with that property. Anyway, that's it's kind of a small world type phenomenon. But Joe Gogan made this remark about how he found model checking to be so kind of brute force, because you were like enumerating kind of states one by one, and surely there was a better way. And that kind of stuck in my head, and that kind of pushed me a little bit towards types and these more quote unquote compositional approaches.
Cool. So yeah, I guess I'll kick off the story of this paper, because it really started with a few things involving Jordan, who may or may not be our mystery guest. But there was sort of a convergence of information flow policies and the liquid types that Ranjit has been working on. So for a little bit of background, Ranjit has been doing this really, really cool work on liquid types. So like I assume everyone here knows some languages, well, most languages have some notion of type. The types help you classify the values. Some languages have static types that get checked before you run the program. And what's nice about that is you can eliminate whole classes of errors at runtime. And so there's a notion of refinement type, or let's actually say there's a notion of like value dependent type, which is types that depend on the program values themselves. So instead of just an int type, you can have a type like int that's greater than 0, or int such that Hongi can see it, or int, you can have all kinds of properties on these values. And then the crazy thing about them is there are ways you can prove that these types hold statically before you run the program. And that's very cool. But there's a very big way that these types fall down, which is, as you can imagine, to prove before you run the program that these types hold, there like usually is a ton of heavy lifting. You start hitting undecidability. And so like, what's bad about having undecidability in a type checker? Some people say not bad, you just restart the type checker. But if you end up having a lot of undecidability, your type checker hangs, you go take the rest of the day off, you show up the next morning, how do you know if your program was just really hard to prove, or it actually like will never stop? And so when it comes to usable type checking, so if you're not trying to do like a full-on verification, like trying to prove like an operating system won't crash or a space shuttle will like go to the right planet or something like that, you actually do want decidability if you're doing these like very heavy lifting properties. And so the really revolutionary thing that Ranjit has been working on is decidable type checking. And like one thing that our collaborator Nadia realized, well, I guess Ranjit knew this the whole time because he made it. But the thing that Nadia realized a bunch of years ago that was really, really cool was that if you have a decidable type checking routine for this, you can actually use it as a reliable subroutine for a bunch of other stuff. And so Nadia had this paper, which was like, you can synthesize, you can synthesize all kinds of programs by using decidable check, like type checking as a way to, see if it's the right program that you synthesize. So Nadia was working on that. I had been working this whole time on a language for automatically enforcing information flow properties. So like you can separate the definition of access policies from the rest of the code. And, I was extending this to the database. So you can like just put data access policies on the schema of your database, propagate that automatically throughout your code. And that's that. And so then Nadia was doing this work. She was my group mate at the time, and I was doing all of my stuff dynamically. So we were like putting information flow policies on database schemas and like dynamically propagating those policies throughout the whole program, which is like super, super, super high overhead at runtime, as you might imagine. So I was like, yo, Nadia, can we do this work for, using like static synthesis, like somehow you encode these properties and then we statically synthesize the policies. So that was the first paper that Nadia and I worked on. That also, we started this work in 2015. It got published last year, ICFP 2020, got rejected 5 times. People are like, why? What is this? What's going on? But like one nice thing is, if you're getting stuff rejected, don't worry. We ended up getting a distinguished paper award at ICFP, which was pretty cool. But it took us a while to figure that out. And then but then I was like, well, my original work, like the whole big thing, if you want this to be practical, if you want to like do real programs with it, you have to do this across the application and database. And so then what happened was we approached Ranjit and we were like, yo, Ranjit. So Nadia and I did this work together, attaching security policies to values and then, propagating them, verifying them, synthesizing them, et cetera. Now we want to do it for SQL databases. So I'll let Ranjit now take over the story because that's where he comes in.
Oh boy, it's been a while. So I guess maybe I should rewind a little bit to before that, where I had been, mm, the here's the funny thing. I think Nadia knows this, but maybe you don't, Gene. The first grant that we got from the NSF on the Liquid Haskell work, like in 2013 or 2014, was called, it had literally the same title as this OSDI paper. It was literally called Refinement Type for Secure.
I think you might have mentioned this at one point, but yeah, I forgot.
And so so at the time I was like, this would be a cool thing to do because there was like your stuff. I think some of the earlier papers had come out, right? I forget, the Jeeves perhaps had come out, and Dejan Stefan had this Hail system, and anyway, there were all these papers. And I was like, would be cool to do this kind of statically, but I had no idea how. Like, I didn't know how to do information flow, and I was kind of, we had no idea what to do. And then really this paper, this Nadia and your paper, the Lifty paper, was like, oh, this is how you can do information flow with refinement types. And so that was like one kind of big piece. It's like, oh, I see, now you can actually start talking about how you can even propagate sort of
I'll link
security.
this.
So that was that. And then, but yeah, the second big hassle was, how do we I guess the second big problem is, how do you connect with the database? I guess this is like, there's no nice way to put it. So I think we had a lot of trouble publishing this particular piece of work, much like you had a lot of trouble with Lifty. It was like all of this, and then once Lifty got published, we were like, well, this is just Lifty, so what is new over here? All the stuff has been done in the Lifty paper. Why are you people writing another paper?
Oh yeah,
And
this was, I mean, I had this with when I did Jeeves and then I did Jacqueline. It took me like, Jeeves was 2012, Jacqueline got published 2016. Everyone was like, you already have one paper on this, why do you need to do it for the database now?
yeah, what's the but then I think the realization we had is, I mean, often I find when this happens, it's, I think, various people have made this point. It's, as an so by the way, I kind of moonlight at Amazon right now. I'm a scholar at Amazon AWS.
Scholar.
Yeah, that's what, it's like that's my official title, scholar. But one of the things they're kind of really keen on at Amazon, I shouldn't be saying this, is everywhere. So is you have to focus on the customer. It's like, the customer is always right. And I remember when I interviewed there, they were like, well, who's your customer as an academic? I'm like, well, my customer is, the people reading the papers, I guess, or the reviewers. So if the reviewer says that, there's nothing new here, what it means 9 times out of 10 is that you haven't shown your light on what the new bit is. You know what? And so that's why I think this most recent version was a complete rewrite. We kind of rewrote it, and even the name Storm, by the way. So back in the day, you recall when we started, it had a totally different
It was
name.
called Bina.
It was called Bina, and there's a kind of historical reason for that. Uh, but then we changed it just for this very last submission because we're like, when you say Bina, you're not focusing on what the new bit here is, which is really the ORM,
Hmm.
the interconnection with the database,
Yeah.
which is really where the new stuff is in for this particular paper. It's how can you specify policies that are,
Yeah.
pretty much they just take the data model, take what you write anyway to describe your database schema, and then write these extra little things, and then let the machine do the rest of the work. So anyway, I think often with these things you have to kind of reorient how I don't have to. You have a startup, Nikki, Gene. Sorry, so you know exactly what I'm talking about, right? You have to kind of pitch
Yeah,
things the
yeah,
right
no,
way.
absolutely. I think pitching the ORM layer generally to the PL community has been really hard. I feel like for me at least, when I did the Jeeves language for automatically enforcing information flow
Mhm.
policies. That was sort of how, like, that was the first step on my path to getting into APIs, because I started building a conference management system using my Jeeves prototype. I
Mhm.
started calling out to the database and I was like, oh no, all guarantees are subverted the minute you call out to the database. This is all a lie. How is not everyone in programming languages talking about this
Right.
giant gaping hole in all of our theories?
Mhm.
But yeah, so then I spent the next 4 years trying to publish the paper that extended the programming model to SQL-like databases, and it was super hard. um, it took a while actually to get the theory clean. It took even longer to get the explanation of why should people care very clean. And it was interesting because, like, I feel like the Storm paper went through that exact same process, and a little similar, maybe different.
No, it's very similar, but it's very similar, but it's again. I mean, I would say the why am I being so positive? I should be more negative. No, I'm being positive in that I can't blame. I was blaming the reviewers all this time. No,
Wait, do
I
you
don't
want to
want to
just
blame them because we were
do
just
you
not telling the story the right way.
do you want, well, yeah, so I think for a part of the story, so what happened is, in 2018, how this project got handed off was actually Jordan and I were finishing up his master's or his undergrad thesis. Actually, this started as Jordan's undergrad thesis,
Yep.
and it we just realized there was an insurmountable technical challenge. And so then we had to be like, well, Jordan's graduating, I'm leaving to do Akita, Nadia, please take it over. And then once it got taken over last year, it got submitted to ICFP. And do you want to say what happened there, Ranjit?
Oh God, I don't really. I thought we weren't going to go there, but I mean, what happened is there was this kind of race condition where we submitted both the Lifty paper, which poor thing had been kind of rejected so many times, and that it still hadn't gotten in. And we had gotten this work to a point where, there was some stuff to be written. So we wrote it up and we sent them both to ICFP. And then, do we want to get into the details of this really? There was
Yeah,
some
yeah.
concern, there was some concern that, that we had that the two papers had, the authors had, there was some plagiarizing going on. It was
It's the
not
same
only that it was the
authors.
same thing, it's like this is the same authors and you people are like plagiarizing from the other paper. And I was a little upset at that, to put it mildly. But you know, I have the fortune to work with lots of excellent people on this paper. So Nikki, who's one of my former PhD students, who by the way is who invented what is the kind of the key technical piece that makes all of this work. So it's almost like, I guess the two pieces of the puzzle are, Nikki wrote this paper in 2015 called Bounded Refinement Types, which is this
Yeah.
sort of, I mean, it's a very clever idea, but it had just been sitting there. And then Rose figured out how exactly you can use the bounded refinement types to do all this database kind of API shenanigans, right? And that was just very clever. It was like, whoa, that was a kind of, head exploding kind of moment. These are the two pieces that make all of this tick. But anyway, yeah. So the ICFP, the reviewers were like, this paper is almost the same as the other one. What's going on? And we said, well, it's not the same. This is like this. We say very clearly, this is from that paper, and it's what is new. Now, you may not like what is new, but we've clearly told you what we think is new and what is not. Anyway, the bad news was our paper didn't get in, but the good news is the Lifty paper got in, and got a distinguished award. So fantastic. And then we knew that we just had to kind of write this a little bit better.
Yeah, and so without further ado, should we get into some demos before we explain? So I will say, like, the really, really, really cool part of this paper is that, like, the Storm is actually doing static proofs against database calls all in a fully decidable way. And like, these are database calls that can like actively depend on each row individually. So you can have policies that say, like, in this row, if you have like in this row, if something is happening where like this is a user, only their friends can see their data, like you can have those kinds of policies that are verified statically across the application and database, and it's decidable. So that's very cool. And so before we get into demos, I was thinking we could actually bring on a special guest who will be very, very happy that this paper is finally in.
Hey everyone.
It's Jordan.
Hi, Jordan.
So Jordan, has not seen a demo of this paper, but Jordan sort of got into this whole situation as a junior in college because his friend convinced him he should work with junior faculty members instead of senior faculty members. And then I was like, well, there's this project I was thinking of doing, but if you like the idea, we got to talk to this guy, Ranjit. And so then we started working. Yeah, Jordan, you want to tell your side of the story before we get into demos real quick?
Sure, yeah. So when we started to work with Ranjit, all of a sudden I had like 3 meetings a week on my calendar. It was like with Ranjit, and then with Ranjit and Nikki, and then just me and Jean. And it was like all week I was only talking about refinement types and security, and it like really took over, and it was really fun. It was a great time. And yeah, it's at the end when we both had to leave and we came on that insurmountable technical challenge, I was disappointed that we couldn't see it through. But I got some emails very early on when I started working, and I saw that someone else was taking it over, so I was happy. But then I didn't hear about it for like 3 years, and it was very exciting when I found out that it was getting published.
Yeah, so now this is, Jordan has never seen a demo of the Storm paper before. So this is the Storm system. So Nico, you want to take it away?
Sure. So I'm gonna share my screen.
I've never seen Nico give a demo, I should say.
Well, I do a demo.
Anxious parent / hawk /
There's
whatever.
a lot of new things going on here. As Hongi said, major drama.
Yeah, can you see my screen?
Yep.
Okay, yeah. So this is the sort of like sample applications we use in the paper and like in presentations we made. And the idea is to make a wish list application, right? So users have like wishes they can post, and then you can go browse to their like wish list and I don't know, like comment on them, whatnot. So yeah, so like at the heart, Storm is just like a web framework. So in that sense, it works similar to other web frameworks. And the special part of it is the ORM layer, in which you define your the interaction with the database, right? So for this application, we're just gonna define 2 models, which is a user, which has a username, password, and email. I know it's just an example. And the important part, I guess, is this wish. For now, we'll have an owner, which means like which is the owner of the wish, and a description with, I don't know, like a description with what the wish is, or I mean, here you can imagine like an image or a link or whatever. Like the description is like capturing that. So after defining the model, one can go and like write and, oops, sorry about that. Yeah. So we can write a controller for the, I don't know, we imagine we can write a controller that we pass in a user ID. And
so can I just say one thing, Nico, when you say user and wish, those are database tables, or what is that exactly?
Yeah, there are database tables. So okay. Yeah, this is like the the ORM part of the database, but this gets translated into a SQL table. So imagine now that we want to write a wish, like a controller that you pass in a user ID and it will list all the wishes of that user. So this is so far like very similar to other web frameworks. But the first thing that makes it different is that because we're using Liquid Haskell, then you can start adding these extra typing annotations, right? So in particular, I don't know if we are gonna have too much time to go into the details, but in particular, whenever you are defining a controller, you have to annotate it with this strange signature. It's not too important for now, but think about it as being the top in the lattice of subtyping. So everything is a subtype of this type. So that's why we annotate controllers with this. This is important because otherwise it won't type check. Well, and once you have everything set up, you can just go and like write the controller. And for that, we can query the database. And we have this nice little like API where you can write these queries passing these filters. So here I'm selecting all the wishes, which has owner equals UID, right? So this will return all those wishes.
So that snippet generates like a select where in SQL. Is that right, Nick?
Yeah, this will get mapped to a select where.
Okay.
And also something that's important here in Storm is that right now we are like getting the result, but we're not yet accessing any data from the wishes, and that's very important. But the way to do it is to project explicitly on the records. So for that, you have this other function project list, and you can project out the description side of the wishes. Right. So the description field is going to be a list of all the descriptions. Yeah, and after that you can just respond. This is just responding with a like a JSON format, status 200 with a list of descriptions. Now to show you that all of this is working, you can also define like routes for the applications, like in any other frameworks. In this case, we are assigning the route show wishes to like the controller we just created, and we have this like syntax UID to like pass parameters to the controller, right? Yeah, so far like it's not. I still haven't introduced policies, and all that makes Storm like great, but just to show you that this actually is working. So right now I'm compiling the code. I'm verifying it, right?
And Jordan, do you have questions or comments so far about how this looks similar or different from when you worked on the original Bina system?
I have one question. Are you guys still using Yesod underneath all of this to actually run the web framework, or are you guys using a different piece of technology now?
No, we're not using Yesod anymore. It's based on like a framework called Frankie.
That Dejan wrote. So yeah, so Frankie is different than Yesod. It's like a homegrown kind of thing. But Jordan, we are using the same database part, which is persistent. I don't know if you remember your wrangling with persistent from back in the day.
Yes.
Which is the library that just talks to the database, and all that filter and entity record and entity field and all of that is still the same.
Got it. Okay, yeah, because that part looked very similar, but the like routing definitions look different than how I remember.
Exactly. Yeah. Yesod does routing very differently. Ooh, what's this?
Yeah. So while you were talking, I just put some values into the database that I had, like I prepared, and this is running in my computer, and I just the route I just defined to access the wishes of the owner with ID 1, and I'm just getting the list of descriptions.
Well, could you talk about what guarantees you're getting from the type annotations that you added?
Yeah,
Oh,
those,
nothing yet.
Nothing yet.
Okay.
This is, yeah, don't worry too much about this annotation. You need it to type check, but you're not getting any guarantee.
Okay.
Now the fun part comes. And so suppose that we want now to mark some wishes as private. So an owner of a wish can say this wish is private, this wish is public, and other users are not allowed to see the wishes that are marked as private, right? So what one can do with that is create a new field. I'm going to make it a string, and this, imagine that this field can be either private or public. So the cool part about Storm is that, like informally, you want to specify a policy that's depending on the value of the access level field. So the good part about Storm is that you can actually go and define that, right? So for that, you can create a policy that we're going to call only public. And a policy is a predicate on a row, in this case of type wish, and of type user. Defines whether the viewer has access or not. Right? So in this case, we can say, for example, that a viewer has access to the wish if it is itself the owner. So we can do that doing wish owner, like we access the owner of the wish. And if that is equal to the viewer, or if the access level is public.
There's a typo on line 9 with access level, by the way.
And yeah, this is already very cool because it's very related to the insurmountable technical challenge that Jordan and I faced. Jordan, do you want to explain what that challenge was?
Yeah, I think where we started to have trouble is we were able to express policies that were only parameterized by a user, but not by the row or anything else in the database. And most meaningful policies are parameterized by data in the database that isn't just the user.
Also, a more basic question. Could you explain, especially for those who don't know Haskell or Liquid Haskell, is the policy, is this essentially a type that you've defined, or is this actually, will this actually evaluate as code?
No, this is not quite a type, but yes, it gets translated into a type.
Okay.
Yeah, this is the part that actually like Rose worked on, is like how to encode this in Liquid Haskell. And I may show you I will show you like the Haskell code we generate from this code. It's very messy.
Yeah, and
so,
then oh, sorry, go on.
Yeah, the last.
So right now it's just a predicate. It says that wish and viewer, think of it as an assertion. It says wish viewer is true if blah condition holds. That's it. We have said nothing about how this only public has anything to do with the database at all. That's what he's going to do next.
Yeah.
Okay, cool.
So after you define this predicate, you can attach it to fields. And for that, we have this syntax. So you define a read policy, and you specify a list of fields. So in this case, we're just gonna attach it to the description. And now we mean that to read the description on a wish, the viewer has to satisfy this policy.
Which is to say must be either the owner of that wish, or it must be that the wish was somehow marked public, right?
Yeah. So if we go back to our controller, so one thing to notice is that the response here is implicitly sending the result back to the session user or the authorized user. So if that user is not the same as the UID we're passing, this shouldn't satisfy the policy, right? Because it's trying to access all the wishes from that user UID. So we may be sending the private ones as well. Yeah. So if we go and try to compile this, it should complain.
Oops.
Hopefully it will complain. So right now it's like doing very heavy work, sending it to the SMT solver and stuff.
Blah, blah, blah.
Okay, so it's
building from scratch. Oh, there we go.
Oh, the complaint.
Yeah, it complained. So it's saying that when we, I must admit that the errors are not very helpful. But what it's saying is that when we try to project the description about the wishes, Storm is not able to prove that the viewers, that the people that are going to see the description have access to it.
Because in fact, they don't have access.
Yeah, because in fact, they don't.
Yeah.
So the way to fix this is that we can access the which is the current authenticated user, and whether if he's seeing their own wishes to someone else's wishes, we can like issue a different query. So in Storm, you can do this first, calling this function require host user. And then because we want to access the ID from that user. So this is returning a record of tag user as we define it here. And these records have an ID. So what we're going to do now is project the ID out of that viewer. And now we can branch on the value of the viewer ID. So if the is equal user ID, then we can.
And Nico, could you explain the quote syntax to people who might not be familiar?
Yeah, actually, I don't think anyone familiar with that because it's unique to Storm.
Which quote are we talking about? Oh, the tick
I think
there?
you're talking about this user ID quote or wish owner prime stuff, right?
Is that what you meant, Jean?
Yeah, like, is that doing something special?
So for Storm on the behind the scenes, for each of the fields in the tables, it creates one of these. We call them. I think this comes actually from persistent. There are entity fields. So it's a way to track in the type system all of the fields in the table. And but what Storm like does extra is that we associate like refinement types to this project, to these entity fields. Yeah, but I was saying is that we can, if the viewer is not the user UID, I think it should be UID, we can select only the ones that are public, right? So we can sort this in the wishes. So right now, this should type check, right? Because if the viewer is not itself UID, then we're only accessing the public wishes. So if we try to compile this.
Cool. And while you're compiling, I think something very cool about this to point out is like a big part of what was hard about doing the Storm work was like basically encoding the database semantics in terms of these bounded refinement types that Ranjit and Nikki came up with a few years ago. And maybe Ranjit, you're the best person to explain like the role of the bounded refinement types and all this.
You want to think like it compiled, but it had because it changed the database. It's complaining because the database that I had is not like compatible. So if I remove the database and I run it again,
you can rerun.
It's missing the column.
It's missing the column, exactly, because we added this access level column. Right? Oh, okay. So right. So wait, Nico, are you done?
I'm gonna have a lot more stuff on how to make this like even more complicated policies, but I think it's
well, while it's running, I was thinking maybe you could.
Yeah, I mean, so the hard bit is this. So if you look at, maybe I'll just explain it with an example. If you look at Nico's code, if you look at his code pane, there's a lot of interesting stuff going on. It looks like nothing's happening. You wrote that policy, you wrote this stuff on the right side, right? With the model where you wrote this policy and blah, blah. And now over here, it's like, that's it. How come it does the check? So if you see what's happening is between lines 28 through 30, okay? What it's saying is, if viewer ID is user ID, then it issues one kind of database query, and else on line 30, it issues a different kind of database query. So the hard bit that you have to, the sort of this difficult technical problem was, how do you at the type level reason about what exactly is being returned by those database queries? Okay, so in one, the database queries wish owner equals UID, and the other one is equals UID and wish access level is public or whatever, right? And what's even more difficult is that in order to get this to work in the type checker, the way we have to rig it is so that we just get to come up with suitable type signatures for what equals means and what and means. Like where equals and ands are these two kind of operators or constructors, if you wish, that are being used to build the database queries. Okay. And so if you kind of drill, let's pick the and. I think and is interesting, right? So if you look at this line 30, the and query, what it says is, you give me one subquery, wish owner equals UID, and you give me whatever the second conjunct is, and the output is whatever this logical combination, right? This conjunction of these two subqueries. And so what you have to reason about, or what you have to reflect at the type level, is you need to say something like, if I give you a first query Q1 that returns records satisfying some assertion A1, and I give you another subquery Q2 where each of the return records satisfies some property A2, then the result is going to be a new database query. When you run it, all of the records will satisfy A1 and A2. I don't know what A1 and A2 are. I don't know what it is at all right now, but you will have to kind of solve for that when you're doing the type checking, right? And this is what bounded refinements let you do. They let you write kind of very fancy types that say, oh, you can have one property on the left on your first input, you can have another property on the right input. I don't even know what those properties are, but I will guarantee you that the output satisfies some kind of new invariant that is connected with those two properties. And you need to do that not just for the queries themselves, but also for the sets of fields that they access. So for example, this left query looks at wish owner, and this right query looks at wish access level, right? It looks at the owner and the access level fields. So somehow you have to kind of combine which parts of the rows are being looked at by each of the subqueries to give you to tell you what the security properties are of the super query. And you need to do this for, like selects, but for sort of selects, updates, and so on. And I think the trickiest one we figured out quite recently was how to make this work even for SQL joins. So you don't have to write like nasty nested queries. You can just like use joins quite compactly, and you can get very precise reasoning. It's a bit technical, so I don't want to get super into the details of it, but that was really the hard bit that Rose kind of really figured out, and that was a kind of whoa.
Yeah, and for people who are curious about like, what's the contribution here or why is this super cool? Like this is all happening at compile time decidably. And so like the nuts thing is like when I was working on the previous project to extend the semantics of something across the application and database, I spent like 1 year figuring out how to model the database semantics. And so what bounded refinements let people do here is you can just kind of like encode the semantics of the database like as like, well, like would you call it a function or like a predicate or
It's a constraint. It's really a kind of logical constraint, but the logical constraint looks a lot. It's called a horn constraint, and I mean, these are all related. Horn constraints are kind of an abstraction of how of they're sort of an abstraction and a generalization of something called data log, and data log is kind of connected to SQL. So this was a somewhat happy coincidence, but it's a logical constraint is the way to think about it.
yeah.
At
And
the
I
end,
think, yeah,
Mhm.
oh, sorry, go on.
No, that was it. It's just like
Yeah,
a
and
constraint.
what's really cool to me about this is sure this work took like 4 or 5 years to do, but once this is done, you can really like call against anything else with any other semantics in this way, not just databases, which is like very, very, very cool.
So I don't know if Nico has an example of this, but one of the things I remember we kind of talked about this and we were kind of, well, we'll cross that bridge when we get to it. I don't know if Jordan remembers. An extra really interesting kind of property that you want to talk about is where um, the policy on one table depends on values in a totally different table. So I don't know if Nico, you can just show us that example because it's one of those things we spend a lot of time thinking about it, and it's a recurring theme in research, at least in my experience, but I think many people will tell you this, where you start working on a thing and it seems completely impossible, and now that we know the solution and it works so nicely, we're like, wow, why were we so stuck on it for so long? It seems totally obvious what we had to do.
Yeah, I totally have it. I came prepared.
Yeah, while that's being pulled up, I was curious if you could talk about like what are the limits of the types of queries that this is able to support? I imagine you probably can't support dynamic queries. So I imagine that, or maybe you can. So I was curious if you could talk about that. And also, are there certain types of queries that you currently don't support?
Can I ask you though, what do you mean by dynamic queries before I answer that question?
Where maybe you're actually taking parameters from a request, so you actually don't know at compile time necessarily what the column names are, for example. I imagine that's going to be very difficult to handle.
I guess in our case, we always know what the column names are, because I mean that's just by virtue of
Mhm.
I mean, not just this ORM, but yeah, so the column names themselves, well, let me rewind. So if you look at this
Sure.
one example, Hongi, so one thing you'll notice is that this value UID that comes into the controller um, is being fed into the query, right? On line 24, it comes in as a parameter. So this is a dynamic value, right? The
Right.
value itself is dynamic. It goes into the query, wish owner equals UID. So the query is being constructed dynamically. And in fact, in addition to all that, the actual query we're running depends on the value of this predicate. Is the viewer ID the UID or not? Right? We're actually generating different queries depending on what particular UID you're asking for and who you are. You see
Mhm.
what I'm saying? So there
Right.
is a great degree of, yeah, I mean, a lot of it is quite dynamic at that level, but certainly, so yeah, I don't know if that answers your question. I wonder if
Sort
you
of.
meant
No.
something else.
Yeah, no, I think that totally makes sense. I was thinking of a situation where maybe you take a parameter and you don't know ahead of time, you know that the parameter should be one of the columns in a particular table, but you don't know which column it is. And you have to,
Mm,
you have to write some code basically to say, oh, I select this, this
I
column
get
name
it.
from the table.
I get it.
Sometime. Yeah.
I think you could I mean the way I imagine doing that is would be some function that takes the parameter value and then tells you which column to pick, right? And then
Mhm.
you use that column to generate your query, right? Select where the value of this column is equal to something else. So yeah, I think you could totally do that.
So,
Um,
so you
yeah,
can
Nico.
always do that if you. I mean, suppose you have a branch and you branch, depending on the result of the branch, you select one or the other
Mhm.
field. So if you do all the queries, like in each branch, you put the entire query, you'll definitely be able to do it. I
Right.
don't know.
Okay. Yeah, that makes sense. Yeah.
Yeah.
Okay.
But yeah, right now, yeah, we are counting on this to be static, right?
Gotcha.
Sort of like what I did here. I could have tried to write it a bit differently and start with this filter, and only if the viewer is different than that, then appending this other one and so on. But yeah, but because I put them like the entire query in each of the branches, it makes it easier for Liquid Haskell.
Yeah, and something to point out is that this whole framework is statically typed. And so in order to make well-typed calls against the database, you do need to know what the columns are.
Mm-hmm.
Yeah, the
Yeah.
other thing I wanted to mention is, yeah, types of these equality operators and ands and select lists use these bounded refinements and actually very hard to get right. But the user, in our experience, like writing code with TORM, the user don't have to write these complicated bounded refinements.
Mm-hmm.
So that makes it, I think, is I can see people using this that are not experts in refinement types.
Cool. In the interest of time, let's actually have like a bit of discussion with Hong-Yi about like, what can a programmer like Hong-Yi take away from something like this? Who, he works at a company, he's interested in securing things at his company today. What can he expect today, 5 years from now, 10 years from now? And then depending on interest, we can continue the demos either in here or on Discord video.
Yeah, sounds great.
Yeah, did you want to ask us stuff? Or
Sure. No, I mean, I think I started with that question. Yeah, I guess one thing that I'm curious about is like, so this work is obviously really interesting, really awesome. How do you envision this transitioning to what developers are currently using today? Because a lot of it is like, well, nobody's really using Liquid Haskell or this sort of web framework just because it is so new. And like, do you see ideas from this like being easily translatable, maybe some of it into existing frameworks?
that's a good question. I don't know. Nico, do you want to take that? No.
Yeah, a couple of thoughts. So one thing is that you can, I guess, a bit on the style of Adam's like work, that you can think of like a DSL that does something similar. So you have like a restricted language that you embed in your like host language or something. And if you like implement it like that, I can definitely see this being applied like in the industry. Yeah, and the other thing is that this is Haskell, and yeah, we understand that not many people use Haskell, but I think a lot of the ideas can be used and ported to like other languages. I myself, I'm working right now on implementing liquid types in Rust, and I think if we get that done, we could do something similar to this.
So I'll take a whack at that as well. So I want to say two things. One is one of the things I'm really excited about this work is that it's a very, very different kind of use of this kind of dependent slash refinement type technology than the kinds of things one usually sees, which often have to do with integers, sort of lengths of lists, sizes of dimensions, and so on. And so what we found in the course of doing this particular work is it's pretty wild, the kind of policies that you A, want to write, and B, that you can write. They're really quite broad. And it's quite nice that it all fits nicely in this framework. So that's one. Two, I think, as Nico said, once we have this notion where you can just have this data model and you attach these policies on, I think in principle it's plausible to start, applying these ideas back, perhaps with dynamic checking, perhaps with sort of other kinds of typing machinery, as in the case of Rust and so on, to things like Django or like web frameworks for Rust and so on. So yeah, I think I think those are the two kind of vectors by which I see this thing kind of having sort of longer term influence. One is it's just like a really cool set of new things you can do with this machinery. And two is that I think it can be folded into other languages, perhaps not exactly in this way, but in in related fashions.
Yeah, no, those sound like fantastic follow-up projects. So hopefully someone will work on it. Cool. Yeah, I was also wondering, could you talk a little bit about the types of policies that you can write? And so I think you mentioned that it can be really broad. Are there any limits to the types of policies that you can express here?
Nico?
So I can answer with an example of something we cannot express. So something we cannot express is a policy on the lines, you can only see this, suppose you have an integer field and you want to put a policy on the lines of, you can only access this field if it is the maximum in the whole table or something like that.
Okay.
And what do I mean by that is that we cannot express, I mean, I'm not saying that we cannot currently express it right now. But I think it may be possible. The thing is that right now we cannot express this like aggregate policies that mentioning aggregations on the table.
Okay.
So I think but there is a more fundamental kind of restriction where I would say all the policies that we have that are convenient at least are of the form you can do something if something else exists in the table. So for example, if you stare at Nico's screen on the right, it says that you can access some wish description if you happen to be a follower of this user and that user has accepted your follow request or whatever, right? What you cannot say is that you can do something if something does not exist in the table. So that turns out to be a kind of you see what I'm saying? So you can't say things like, oh, you can see this wish as long as you are not on some blacklist or something like that, right? negate. So it's very constructive. It's very positive, where you can do things as long as there's some evidence in some table that says you can do it, right?
Gotcha. Okay, so it constrains a little bit about how you construct the schemas, I suppose.
Exactly.
Of your database. Okay,
exactly.
That makes sense.
But,
Cool.
But the other thing about expressivity is that you can always sort of bend it. And in this particular case, because you can do it positively, you can imagine making the opposite of the table, right? Like the complement of the table. And you can even make that with I don't remember the exact term, but there is like this virtual table you can have in SQL. So you can store the table you want to store, and then you have this like view onto the table that is actually the complement. So you could sort of bend it, right?
Right.
Yeah.
I think this is what Hongi was alluding to also, right? In kind of trying to shape your schema so that you can say you want positively, right?
Yeah. Cool. I know we're running out of time. So this is less of a question, more of a comment. I think it would be really cool, maybe more of a quality of life suggestion is, so right now, this gives you safety because essentially your setup is checking against turning the policies into constraints that you can check against at compile time. It would be really cool if you could also maybe have some way of automatically turning those into filters in the code itself, so that developers don't have to manually write. If they know, like, well, of course, I've already written the policy. I know what data I want to be able to return. Can I just annotate my controller route code so they can say, oh, apply this, or apply the the policies that are already defined as a filter, or maybe some sort of view into the database, if that makes sense. Because it's, and I don't know if like this is the best example, but I sort of see you've expressed your policy, but then you've essentially duplicated the logic behind that policy in your code as well, to say like, oh, of course it's, your ID is the owner, then return one query and otherwise return the other query.
Yeah, so this, Hongi, this is actually very related to the Lifty paper with Nadia, where Nadia figured out how to do synthesis for this in the application layer. So my dream for like the end game of all this work was, Ranjit has actually done some really cool work on refinement types for JavaScript. So with one of my students, Travis, we were actually working on like adding, like taking Lifty and so like the synthesis stuff and like synthesizing filters with refinement types in JavaScript, and then like the next part would be to hook it up to the database, and then one day also synthesize the database queries with the right filters. But yeah, I don't know, this is like a lot of work, so I don't know if anyone will do it.
I wanna argument against that actually.
Oh, really? Okay.
I wanna argue that you do wanna duplicate the policies, because the policies are not only there in the code, like the checks are not only there to verify the policies, but they're also relevant to the application's logic. So look at this example. So right now the check, or the policy check, is that whether the viewer is equal to UID. But if you think about it, the logic of the applications actually depend on that, because you do want to return a different list depending on whether you're the user or not. So what I argue is that the same logic of the application conforms to the policies.
I see. Okay, I think I see what you're saying. I think you're saying that the policy is just representing a constraint, but that's not the same as expressing the actual desired behavior of the code. So you actually need both. I think that's totally fair.
Oh, well, so Nico, like part of the work with Nadia and part of my earlier work addresses this very concern, which is the policies actually gate two values, because something I realized pretty early on is if you want to automatically enforce policies, something needs to happen in the error case, and it can't always just be propagating an error. And so Nadia ran into this again when she was doing verification, and I was like, yeah, what we did was propagate a default value all the way through. But like that kind of breaks down some, like you kind of like, you can't really like retrofit a system with it. Like it's basically like you are doing like default value oriented programming or something if you do it that way, because then you're always like, okay, this thing is either going to be this value or this other kind of value, or something like that. But yeah, because of my many years working on this, I've actually concluded I think automatic enforcement is like very tricky for this reason. And so whenever companies say they're going to do it, I'm highly skeptical, and I tell them it's a bad idea.
So I should just say, I think this is Nikhil on the chat. I was going to say the same thing. The policies are way shorter. That's the main. This was the
Yeah.
another thing I was going to say in answer to your question, Hongi, is that what we found is like the app logic is quite complicated. It's like, several thousand lines or whatever. But the policies themselves are really compact and easy to audit. They're in one place and right next to
Yeah.
your database. It's just like, oh, okay, I get it. This can read, that can write, this can do this can do that, and way more declarative. Exactly so.
Yeah, and you
Yeah, I
don't get
think-
the policy spaghetti. Oh, sorry, go on.
Yeah.
Yeah, no, I think that totally makes sense. I was thinking of the policy as doing more work than I think it sounds like you're intending it to. So that totally makes sense.
Cool. So we're actually at the end of the in like the specified time, and I don't want to hold so many people here longer than we're supposed to, but I also know Nico has more demo, and so I'll propose this. Something some of our speakers have done is gone into the Discord. So what I'm going to do is send an invite to the Discord. What you can actually do is video. Like basically demo inside of Discord with video. You can do either voice only or with video. So I will suggest like we just kind of meet there. And Nico, then also people can watch. They can also like chime in. It's more of it's like a small group discussion afterward. So I will send an invite to the Discord, and then everyone who's interested in more demo from Nico can meet us there. And then if people are like, I want to have my Friday because it's summer, like no hard feelings, except for maybe Nico will be like, hey, I had more demo. But yeah, thank you so much, Nico and Ranjit, for coming and presenting this. Thanks, Jordan, for coming on. Yeah, thanks, Hongi, for asking all the questions.
Very good questions. We should have a longer session with Hongi sometime. I think he would be.
Yeah, Hongi is going to be very in demand. Like all these academics are like, Hongi, we want you to consult with us.
Okay.
All right. Thanks, everyone.
Cool. Thank you, everyone.
Bye.
So wait, logistically, next week we have one more scheduled session with Rob Ricks. He's been requested by both Pierce and Quinn, who run the Slack and moderate the chat. So they both are really excited about Rob. He does like implementing abstract interpreter something at GitHub, which is very interesting. So he's on an applied research group. They're doing a lot of stuff with code at GitHub. So Rob will be talking about that. And then after that, TBD, Hongi and I have to decide who's the rest of the summer. So tell us what you think. Goodbye.
Have a good weekend.